Okay. Well, so how to build software? Very little, I would say, like very little compared to awk. It is even a little language, okay, and but very useful. Okay, it saves us so much time and effort. Well, so one concept that we need to understand is this: does MSH4.c need to be compiled? That's the question that make actually addresses, and see if you can answer this question. What does this question mean, right? We do GCC, right? We do GCC that file, right? -o, MSH, and so on. Do we need to do that GCC on this C to get the latest version of the code? No. Why? Because you see here the latest version of this code was created at 1406, and this executable, this is the executable. So this is our code and this is our executable. We want to make sure that the code is updated on this executable. Here, this executable was created after the last edit on that C file, right? So that's why we don't need to compile it again. Okay, this is the key concept that make uses. Okay, if we need to compile that, if the executable is updated or not already. Okay, how about this? Do we need to compile this? Yes. So we did the last compile on September 26, 1409. And now the next day we updated our C file. So if we want to use the latest version of the code, we definitely want to do GCC. So that is the key concept. That's what actually make can help us with, okay, to keep track of those kind of thing. So if we have a project with like 10 files, so if we want to keep track of all of those, like 3 of them are updated, if we want to manually find those, that can be a little bit a hectic job to do if we have more files even, okay. So make can keep track of those, okay, and make sure it updates and compile only the file that needs to be compiled, okay. And that's what I mentioned. Okay, so the structure of make is, okay, so this is an example make file. There is a target and the component that it depends on. So we want to create this MSH and we need this. We can add multiple files here and we have a list of commands. Okay, that is another target. So, and we have this command. So we have a target name, a list of component, and list of commands. So that is like the simple basic structure: target, component, command. And this whole thing is called a rule. Okay, this is called a rule. So we can have multiple rules with the same structure. That's it. Okay, we have multiple rules. That's the basic structure of make. There are some other variables and everything you can do. There are some advanced stuff that you can do, but that's the basic structure. Okay. And what this basic rule says that the target, this target depends on components and run all these commands to build the target from the components. So in this case, this is our target, which depends on msh.c. And how can we build this target? Executing this command. In this example, we have one command, but we can add more commands if needed. Okay. In the same case here, there is no target, just a command. Okay, just to remove files. Now, again, this is our example make file, touch msh.c. Can you tell me what does this command do?
Create msh.c as a file.
Yes, it creates a file, but we already have that file. What will do that? We already have a C code. Okay, it's not that like a very critical important for you to know. So this, let's update the time. We talked about it before, but we just update the last time, right? So even though we don't make any change in the code, if we say touch message.c, it will update that timestamp. And why do we want to do this in this context? Just to test that make file, because if we update this file to latest timestamp, then it will consider to recompiling it. Anyway, in this case, it says that .c is updated, right? Here it says the .c is updated, so we need to compile this thing to generate a message. That's what it does. Okay. Now here we just say make. So how does it know that it has to use this file? Actually, that is a part of built-in feature for make. It looks for make file, small m make file. There are some other variation. It has built-in file name that can use. You could use your own name and add that name here, but by default, when you have a project, we normally keep one make file and do add all our rules there. Okay. There are a couple of variations of file that the make accepts. Okay. And yeah, so it look for file name make file. If there's a make file, it will by default use that. Okay. And if you give a target file name, that will okay, so that target, actually that target is, you can say make clean or make msh, you can do that. But if you don't give any target, it will just focus on the first one. Okay. So here is this example, this make clean. It does not depend on anything. It's just remove some files, and that's what it is doing if you call the make clean. Okay. And just one extra important thing is here, you see, you are invoking a bash command, right? Remember, this $sign is for bash command. This dollar actually a special character in make. Okay, it uses for itself to declare variables and stuff. Now you remember we discussed the same thing in our previous awk. So and is a keyword, or when we have some keyword or some special symbol for that language, we need to do some extra stuff to use it is for regular purposes. So makefile has $symbol for itself. Now, if it wants to use $symbol as a regular $symbol, that is the syntax. If you put $2 symbol, it will convert it to a single $symbol when it send it to the bash. Okay, so that's the thing you want to do. Okay, $sign means a regular $sign instead of a special $symbol for make. Okay. Anyway, so that's it. So makefile is not critically complicated. There are some other options you can do, use variables and stuff. You can look into those. Now, this kind of makefile, we provide you with those homework. You will check those. That's actually part of the lab work also. Okay. The next thing is sed, which is stream editor. So you see the awk is little bit more generalized for string processing, but sed is used for editing. Okay, so if your focus is only editing, then sed is something that you can use. Okay, and for awk you can do this kind of thing, and also you can generate report and all of stuff. So awk is used mostly on generating reports on any document, and sed is a focus, a very narrow focus compared to awk is for editing. Okay, it also has those pattern and action structure, a little bit different syntax, but it has the pattern and action structure. And substitution is like, there are a couple of commands, around 25 commands in sed, but substitution is the like most frequently used command in sed. Okay, now here is our file, and you will see, even though the syntax is a little bit different, but you can connect this concept with a grep or awk very well. Okay, now this is sed. Of course, you want to do this, use this command as a bash command, and S stands for substitute. What we are saying is find this pattern and substitute this pattern with OO. Okay, that's what we are telling in this command, right? And you see, it's looking for LA for each line, LA, and then it replaces with O, and it's not going to replace LU, right? Quite straightforward. If you understand awk concept and grep concept, then it is quite straightforward. Okay, so let's move forward. Okay, that's the question actually. Okay, what do you think? Did it modify the tm3.txt file? If you cannot answer this question, it's perfectly fine, but because I did not give you enough information to answer this question correctly, it's just a guess, just to think about. Okay, yeah, the way sed work, it does not update this file. It actually do all those operation and gives this output on the terminal. Okay, so it does not. Okay, update the file by default. We have option to update, we'll see, but by default it just print on the screen. Okay, again, you see sed basic logic for sed is very similar to awk. So it reads each input online at a time and match a pattern, okay, whatever command we have, and write modified data to the standard output by default. So by default it will give the output on the standard output, but we can change that. Okay. Okay, let's see some examples. So this is a file. What we did, we said, this is a CSV file, right? CSV file is comma separated files. Now we want to make it space separated instead of comma separated. So that's the goal, okay? Just see, check carefully. Now, what we said here is substitute comma with space, okay? That's what we told this set to do. And here is the output. What do you think it did? Observe closely and tell me, what do you think it did? Our goal is to convert that comma separated file into a space separated file. Now we told it to do that. Yeah. Okay. So yeah, so many of you are giving the correct answer here. So it only replaced the first comma actually, okay? And so if we want it to replace all of them, and that is another command, we can use G at the end, and it says the replacement needs to be done globally for each sentence. So for each line. So replacement has to be done globally, which stands for, so like G stands for the globally. In that case, it actually replaced all the commas, okay? Quite simple, okay. S stands for substitute. That's the command, set command S. Okay. Anyway, I just picked this name. Do you know any, like, what are the commons among these people? Any common characteristics among these people? Those are like name of 4 people. Anyone? There is a Nobel Prize winning author, an artist, famous guitarist, famous singer. The common thing among them is they all lived in Monterey County, okay, at some point in their life. And he actually born here, okay, and he won Nobel Prize in Literature, okay. Anyway, so that's just a trivia, but the goal for us is to see some regular expression, okay. Now, if we do this, sed substitute, what are we telling here with these commands? So this is a regular expression. Now you see there, it needs to be, we are looking for something that starts with D, ends with a comma, and this dot star, you remember? Anything, right? Any characters, any number of times. So try to figure out what would be the output if we run this.
Dr. I?
Yes.
I'm assuming that when it does the substitution, we're substituting nothing, correct?
Yeah. So it's just replacing with empty, yes.
So all that would be left would be the famous people that lived in the county.
So it's just an ID followed by that number. So it's just we just needed some name for this example. I just picked those names, but yeah, so it doesn't matter who they are. I just wanted to get that entry at the beginning, but yeah. So if you focus them as a string, so for each line, you just try to find that pattern and replace that with empty, okay? Okay, so let's see what happens here. Okay, this is the output. Now, the one important thing to focus here is this pattern we look for. What is the pattern? Starts with D, ends with a comma, and anything in between. You see, this pattern actually is complete from this portion too, right? It starts with G, ends with comma, and something in between. And this block also satisfied the same condition, okay? So when we have multiple block of string that satisfy the same regular expression, we are going with the longest one. Okay, that's the one thing to observe here, okay? So it is starting with this D and going up to the comma that gives us the longest string. And that's what it is replacing. It is just removing that and we are left with the seconding part, okay, right? Okay, in, here there is one critical thing is if you want to write into the file, you might be tempted to do this, but don't do that. So don't, okay? Don't do this. So you see, if you do this and cat people, there is nothing. So because it is reading that file and writing in parallel, that actually messes up thing, okay? If you want to update that file, don't do this. What will you do? You will use that I flag, okay? This is the right way to update that file. If you do this, then sed will manage this updating thing internally, okay? So in that case, you see, if you put this I, and then it will update this file. If you look at this file, that is the updated version, right? Okay. And okay. This is for using extended version. So I am like leaving these things for your reference. You can look into it. Extended regular expression. You can use this if you want to replace this with this. You want to remove this digit. So you replace this. So yeah. So just remove. And there is okay. So you can write files like we saw for awk. You can write files for sed command 2. And that's what it will do. Multiple commands. Okay. Multiple commands. Multiple action. It's fine. And here capturing text, okay, little bit a tricky thing. We can capture a text with this bracket. It will reuse that string, whatever pattern it matches, it reuses. This is a little bit tricky example, so you can try it to see what it does. This is the trickiest example for this whole topic. Okay. Now we have seen a command substitute. There are other commands like delete. So if it matches with 6000, delete those lines. Don't include those lines. Right, the deleted if that means. So that's a delete command. Quit, it keeps going line by line. If it matches with that line, it quits. It does not go any further. So these are the additional commands. So substitute is the most common command as I said, but sed has some other commands to deq. There are some examples. Okay. Anyway, so we don't have much time, but still